All right. Um, Welcome back, everyone, after lunch. I hope everyone had a nice lunch. Welcome to the afternoon session. You can have a little sleep in here. It should be nice and relaxed, and we'll take it easy. If you have any questions as we go through, please get in contact straight away because it's easier to ask the question as part of the context that we're speaking. So, my name is Paul Stack, and I'm here to talk about it's time to rebuild DevOps. Anyone ever heard the term DevOps? Pretty much everyone is starting to hear the term DevOps. It's become very synonymous in IT at this moment in time. So about me, I used to work at a company called HashiCorp, working on Terraform. I then moved and worked at a company called Pulumi on Pulumi. I am a very frustrated infrastructure user because infrastructure management tooling is kind of broken. And I now work at a company called System Initiative, which we'll talk about as we go through. We'll just give some people a minute. So we're going to start with a quote here, okay? This is like a new quote for me that I wanted to include in this, okay? So imagine a world where product owners, development, QA, IT operations, and InfoSec work together, not only to help each other, but to ensure that the overall organization succeeds. Okay, by working together toward a common goal, they enable the fast flow of planned work into production, performing tens, hundreds, or even thousands of deployments of code per day. Okay, now this is a quote that's come from Gene Kim as part of the DevOps handbook. Okay, now in IT we need to work fast. Okay, if we don't get systems through fast for our users, we lose out to the competition. If there is competition, of course, but it's very much a case of enabling and working together to get that fast flow. DevOps is eating the world. Okay, if you don't know where DevOps came from, I'm going to give you a super brief history of where it came from. Okay, so in 2007, a man called Patrick Dubois, okay, was in his home in Belgium, and he was super frustrated about what has been going on in the infrastructure world. Okay, things were not working really well. You were having to push tickets back and forward. Anybody work in Jira? And having to assign tickets to different parts of the organization and waiting for it to come back and see who had worked on it. It was a crazy time. It still is for some companies, but it was awful back in 2007, 2008. Okay, and then in 2008, a year later, a man called Andrew Clay Schaefer proposed the Birds of a Feather talk at Agile conference in Toronto. Now, Birds of a Feather talk is a short talk that is specifically, very open, but it has a target in mind. It has an actual topic that you want to talk about, and it was called Agile Infrastructure. Okay, now only one person went to that talk. Okay, Andrew, the person who proposed the talk, did not go to that talk. Only Patrick Dubois went to that talk because he was very interested in seeing what was happening. Now, they didn't meet each other until later at the conference, and they had a whole conversation. Now we flick forward to 2009 at a Velocity conference, and you had a man called John Allspaw and another person called Paul Hammond, and they gave a synonymous talk at what we believe is the beginning of a new era of the operations world. Okay, it was the talk from Flickr, and it was 10 deploys a day, dev and ops cooperation at Flickr. Okay, now 10 deploys a day is pretty impressive. Okay, I don't care what company you work at. 10 deploys of something a day is actually pretty good, and it shows that you have a great working system. Now, back in 2007, that was wonderful. If you're doing it today, that's still wonderful. Okay, and that's what we still try and strive towards. And while this talk was happening, Patrick was tweeting and said, this is amazing, but it's happening in Silicon Valley. Why don't we do something about it? Why don't we bring something here? And the other person at the end, his name is Paul Nazarat. And Paul Nazarat said, why don't you build your own conference? Why don't you bring Velocity to Europe? Now, it happened. It spawned a movement called DevOps Days. Anyone ever been to a DevOps Day? Anyone seen them? Okay, so they're pretty popular in the operations world. Okay, they're becoming less. They're becoming more well known in the infrastructure world and the software world, but we're not quite there yet. Okay, but it's happened, and like in 2019, before the COVID era, there was 80 in a year, okay? Now this year, 2003, because travel is back, there's still more than 60, and they're happening in cities all over the world, and it's pretty impressive. Okay, so it's happening everywhere. DevOps is a phenomenon, okay? And it can be best explained as people working together to build and deliver software to their users as fast as possible. We used to work in an environment that did this. Some people probably still do, where developers did one thing, and what they did is they created this package of software, and they threw that software across the wall to the infrastructure people, and those infrastructure people who you have to feed nicely pizza under a door because they have their own little office, they don't mix very well with people, they're a bit, you know, everybody in the IT organization used to think the operations people were a bit strange, and this was their job, to keep the system running. So we did it, right? It's been brilliant. Like, we did that in 2009, and it's, you know, it's really worked for us, and we're all, you know, building and delivering software as fast as we can. No, we absolutely did not. It has been an utmost disaster for most organizations. And it's not because of what they're doing, it's because there are companies like Netflix and Etsy and Flickr and all of these large organizations who are telling you should do 10 more whatever deploys a day, okay? Here is the model we use. And what most people do is they pick that model up and they try and put that same model within their organization. And that doesn't work. You can't take someone else's model and put it in your organization. It is designed by them to fit their flow, their system, their way of working. It is not designed for your way. But if we look back at what we're doing, now in 2023 compared to what we were doing in 2007 within your organization, I'm pretty positive you've made huge strides, big changes. It may be faster. You may not be the 10 deploys a day, 15 deploys a day. If you're able to deploy daily, weekly, then that's probably a stride forward to where you were in 2007. The shape of the pipeline has not changed. Okay, we start here, we write some code, it goes through our whole delivery process, and it comes out the other end. But what we've done in the middle is change that pipeline so many times. Okay, we changed from probably source control systems, maybe from like SVN, we've probably gone to Git. Okay, or GitLab or whatever. You've probably changed your continuous integration tool 500 times throughout the time because there's a new one, a cooler one comes along all the time. Containers have been a thing. Orchestration systems have become a thing. The pipeline is the same, but it's got longer with many more steps in it, and it creates a lot more frustration because of that. For me, there are a lot of failures in the current model of DevOps today. Okay, my biggest source of pain is collaboration. Okay, right now, whether it's a good thing or a bad thing, we have decided to store everything in source control. Okay, I'm not debating that source control is a bad thing. I'm debating that what we put in source control is a bad thing, and how we interact with that source control is a bad thing. Okay, pull requests are the most painful piece of crap we've ever had to deal with as software engineers. The reason being is that ego gets in the way of a pull request. Okay, we may think we're nice people, but when we look at someone else's code, we probably are mentally modeling how we would write that code, how we are then reviewing that code based on what we would have done, how we would have named systems, how we would have written comments, and how many people have written a pull request that has nitpick comments in the pull request. Okay, we very rarely look at what the outcome of the pull request needs to be, and we actually go specifically in depth in the code itself. Okay, that is a real pain in the ass to deal with. Okay, and that makes it difficult for us to get it through the system. Now, if you open a pull request, whose job is it to review that pull request? Is it your friend on the team? Is it the architect on the team? Is it the team manager? There is no defined role of who, looking after pull requests. And sometimes they can sit for a longer period of time than they actually need to. And as we're talking about source control, currently in infrastructure as code, and I'm very specifically talking about infrastructure as code here, the source of truth for infrastructure as code is the code itself. Okay? Now that is a horrible idea, that is the source of truth. Because that source of truth is a point in time in one system. That infrastructure as code may fix 10 different systems. It may talk to Amazon, it may talk to Azure, it may talk to GitHub, it may talk to all these different providers. So you don't actually know what is happening in those systems at that time. Okay, because everything is in your source control, and what we usually tell developers is don't touch those systems manually. Now that's all right in theory, okay, but if you have a process and a pipeline that takes 3 hours to make a change to production, and there's a system outage, and you can go and click something on the Amazon or Azure portal in 3 minutes, you're probably going to take the 3-minute option. Okay, why would you want your users to suffer for 3 hours compared to 3 minutes? Okay, now as soon as you touch that in production, that infrastructure as code is no longer the source of truth anymore. So the idea that it's one way, a unidirectional flow of information is actually very bad. Because if you do change it in multiple places, you could be way out of sync in different ways. Let's think of it this way. Okay, I work at a company and I open a pull request on a Monday morning. Okay, that pull request needs to go through a review. It needs to get changes. Due to other work that I'm pulled into, meetings, it ends up that pull request is not finished and ready to be merged until Tuesday afternoon. Now, Monday afternoon rolls around. One of my American colleagues has to fix something in production really quickly and has to make changes to the source control, has to make changes to the infrastructure as code and push it through the system. My pull request was based on a system that was written before that change. Now, my pull request could actually be out of date. It may no longer reflect the real system of reality, and if I try and merge it, it could end up causing a big problem, or it could revert the problem that we had caused earlier. So it's really difficult to understand what happens here, and it's all too common. Now let's think about this type of situation. Anyone use Terraform, Pulumi, CloudFormation? Yeah. How many times have you had a plan succeed or a preview succeed, and when you've actually tried to apply it, you get an error message that looks something like this: plan failed because this something wasn't around and there was something deleted. Okay, because again, you're based on the conceptual idea that the code looks correct, but it doesn't matter what is actually in reality, and when you try to apply that into reality, it's different and the system fails. So it's really problematic. We've made ourselves a real amount of pain here. And there's an opportunity. Of course, there's an opportunity. There's opportunities in everything. This is the current state of DevOps ecosystem tooling, okay? Now, I found this on the Sapphire website, like from last year. Of course, as you can imagine, 5,000 new tools have been created in a year, so that slide looks even bigger. If I asked 4 people in here, how would you deploy an application to the cloud? All 4 people will give you different answers. They will choose different tools. Some people won't even know where to start because you have this. Where do you take this one and this one and this one, and then like it's a complete nightmare to get started. It really is. The ecosystem has exploded, and you end up with what's called the 200% problem. The 200% problem is knowing the tool that you're going to use and the cloud abstraction that it covers. Okay, you need to know 2 layers to be able to do something. Now, we got things wrong. DevOps should be people, processes, and tools. And what I mean by that is like people working together, using a nice process that you defined and the tooling that goes with it to define and work as a system. But what we've actually done is we've reversed it. We've chosen the tools, we've tried to shoehorn those tools into a process that was not designed for our organization, and then we've made people go and fit within that. Okay? Anyone work in an organization where you have been told that you are deploying everything on Kubernetes, and then you've had to go and learn Kubernetes? It's, that's choosing a tool that fits into a possibly not really your process, and then you're the ones as people that have to suffer to learn it. Okay, we've led to causing real problem, and we have to remember the fundamental question of always is how do I change just this part? Why do I need to understand what is happening across my entire ecosystem to change one variable, and therefore I don't know what it's going to do in other places? And it is really hard. It's really frustrating. This is death by 1,000 paper cuts. And I can't stress this enough. It is really, really painful to get started with the cloud today. It is becoming big. It is becoming a beast. And I haven't even gone into the security aspect of it. And we are making so many wide open security mistakes in a lot of our organizations. Okay, we can see that happening all the time when we see all sorts of exploit information. And I don't know about you folks, but my email has been used in many phishing attacks and picked up from many different places, so it always happens. So what's next? Okay, and there has to be something next. Okay, there has to be that next hook to get into. And of course, if you get that hook and you decide and you make something, you can be like Scrooge McDuck rich. Okay, you can actually go and like deliver some systems. Have platform engineering figured it out? Anyone part of a platform engineering team? I'm sorry if you are, because I just poke on you a little bit. Like what platform engineering has done is they've created another silo of people that you have to talk to get stuff done. So developers now have to talk to the DevOps team. The DevOps team have to talk to the platform engineering team, and the platform engineering team have to talk to the operations team. We've just ended up creating more silos. Now, it's a great idea in concept that you have a team that builds an internal platform that you can actually use to deploy your systems and use your systems, but they become part of that problem. They become part of that silo. Now, there is a second wave of DevOps coming. Okay, and I stress this because we've had 14 years of this. Okay, we haven't been successful. We haven't done a lot of what we've wanted to achieve, and we're trying to do things differently. Now, I have to admit, I've led you along the journey to show you what we're trying to do to fix DevOps. Now, what I'm about to show you is an open source tool. It is free. It doesn't exist in production yet. It is conceptual. There are no production users of it. It is a theory by the company I work at to be able to reimagine how it's going. Now, it's important that I tell you that because we are not telling you that we will solve everything. What we're trying to do is to challenge, to think the ecosystem in a different way. So System Initiative is a real-time, multiplayer, multimodal reinvention of DevOps. Okay. Anyone ever seen Figma? Miro? Okay. You know that you can all work together? It's a bit amazing, right? We're building a similar thing for DevOps. Now that's mind-blowing in many different ways because we don't work like that in the part of DevOps that we all work in, or in delivery of systems. And it's going to take a lot of thinking. So let's break some rules, okay? Rick Rubin is an author who wrote a book called The Creative Way. It's an amazing book if you're into product and thinking of how product says. And Rick Rubin says, rules direct us to average behaviors. If we're aiming to create works that are exceptional, most rules don't apply. Average is nothing to aspire to. Now that's very, very fitting here because what we're actually trying to say within the organization, what we're building at this point in time, is that what we've settled for now is average. We hate the tools that we use, but yet we love them because they allow us to do our job. But if we didn't have to use them and we could choose something else, we would drop them in a heartbeat. Okay, and that's not because they're bad tools. That's because what we've started to have to do with them has exceeded the boundary of what the tool was created for. It's not because the vendors have done a bad job. They absolutely have not. They've revolutionized the ecosystem to this point. And what I mean, like, when I worked at Terraform many years ago, there was no loops, there was no conditionals. It was like very, very simple, easy to read infrastructure as code. If you look at some of the Terraform code out there now, with some of the loops and the conditionals that are embedded in it, it becomes actually quite difficult to understand. It was never designed with those in mind, so therefore all of the code that was currently out there was not designed to be written in that way. So when you have to shoehorn those features in, it becomes a little more difficult, right? And I mean, who would have thought that you can put conditionals and loops in a DSL, right? Because that's not really what a DSL is for. It's more about a much more succinct structure. Remember, DevOps was designed to focus on delivery. And as the second wave of DevOps, we're trying to facilitate that collaboration. We're trying to understand the real-time implications of changes, and we're trying to be infinitely extensible. Let's go and have a look at what we're building. How do I... Oh yeah, I'm on this screen, right? So this is System Initiative. Okay, System Initiative is a web UI. Okay, it's drag and drop. We have actually gone back to drag and drop, and we've gone back to drag and drop for good reasons. Okay, so I told you it's multiplayer. Okay, so you're going to see my screen here, and I'm going to do it on my laptop here from another logged in account. All right, very good, and you should see my. There I am. Look, hello. Right. So straight away, we've multiple people being able to work in a workspace together. Okay. And what we're going to do is we're going to build out like a small application. Okay. So the first thing I'm going to do is I'm going to create a region frame, and I'm just going to zoom out a little here. Come on. Just so you can see it a little easier. Okay, so this is a region in AWS. This is where we're going to deploy some applications into. Okay, so the first thing I want to deploy is I'm going to take an AMI, and then I'm going to take a security group, and then I'm going to create a key pair, and then I'm going to create an EC2 instance, and then what I'm going to do is I'm actually going to connect them all. Okay, so an AMI is linked, come on, to the EC2 instance. A key pair is linked to the EC2 instance. A security group is linked to the EC2 instance. We have drawn a representational model of our infrastructure right there in 7 clicks of a mouse. Okay, now of course this is the most simplistic infrastructure that you can imagine and is not like a real world system. But what I've actually done is I have done this in a simulation. Okay, System Initiative works with digital twins. Now the best way to describe a digital twin is if you can think of Formula 1 racing. Okay, you can't take a car, a Formula 1 car, put it on the track, make lots of changes and see what happens, because that's pretty dangerous. Don't do that, kids. Okay? What you got to do is you got to build a digital twin of that. You got to be able to simulate what changes happen. You have the driver who drives in a simulator, the same for a pilot. Okay? You can make small changes, you can see what it does, what it affects different things, what it's happening. And only when you're happy will you take those simulations and apply those simulations to the real world. Same thing can be done for infrastructure. Who would have known? Okay, you want to try it, you want to test it, you want to see what would happen if I changed this. And then you can actually go and see. Now, I didn't set a region. And if we look at the diagram right here, okay, we can see that all of these 4 items are inside a region. Okay, so there is a dependency graph by default here. Okay, because we know that the region has to exist and it has to be available before you can create the AMI, before you can create the key pair, and before you can create the security group. But the EC2 instance can only be created after all of these other pieces that make. So System Initiative is going to recalculate always the dependencies and the changes. So if I set the region right now, then you'll actually see a status bar at the top. And that status bar is going to tell you what the changes are going to make throughout the system. Now, it is a graph of functions. Okay, it's testing the model right now, you calculate, and then you'll see the screen update, right? So it's doing the calculations in the background to understand the implications of what your changes are. Everything here is a function. And the fact that they're functions means that we can execute the functions in the order that they have to happen so we can understand the outcome that's going on. So firstly, it's updating the region. And then you'll see each of the nodes themselves be updated because the functions that are inputs to those nodes have executed and they understand it. So we are now in a situation where we know this is what the infrastructure would look like in the real world because I have set a variable. Now, the interesting thing here is that we have these items here on the left. Okay, these items are called qualifications. Okay, the qualification here allows you to test your infrastructure against the real world in advance. Okay, you can make calls out to Amazon or Azure or DigitalOcean or Google or whatever cloud you want to check, is this the correct formation? Is it, this is the equivalent of like a dry run on Azure. Okay, Azure has dry run ability where you can actually simulate what Azure will do and it'll tell you if it's a good request or a bad request. This is the same style of thing. So you can actually be testing real functions, and it's always because it's real time. It's running these functions against the cloud. Now, I'm running against local stack, so I'm not talking out to the internet because the conference Wi-Fi isn't great to be able to do that. But I'm still able to see. Right? Where is my... There we go. Yeah, I'm still able to see that local stack is running like here for me. And I mean, I don't know where my desktop is, but yeah, like, so I'm actually seeing the API request. It's saying, run instances 412 dry operation, create security group 412 dry operation, execution failure because of credentials, describing the regions, creating key pair, all of these values. Now this is pretty great because we can actually do things in a lot of different ways here. Now just to show you, there is nothing currently on head. Like, where's my mouse? There it is. And you can have as many of these change sets, these simulations open as you actually need to. There is nothing because there is no production infrastructure at this moment in time. Now, if we go a little further, I can then ask you, so we can see what we're doing, we can work together, we can be doing things on calls, we can actually be interacting, and multiple people can be interacting here. Have anybody ever worked with a tool that a release has happened in a cloud vendor's tool upstream, and you've not been able to take advantage of it because you actually have to wait for that change to propagate through into the tool that you use? Okay, we don't need to do that. What we're going to do is we're going to click this little beaker icon right here, and all of these things are just TypeScript. Okay, you need a new property that you need to talk to the cloud and do a new thing, just write it. So like, for example, creating a Route 53 zone, if Amazon release something new tomorrow, then we can go and add the property and we can just update the AWS CLI call. Okay, you just, like, we're not creating anything hugely intelligent here. We're just creating a very easy to scale system, easy to respond to changes, something that you have full control over. Okay, you don't need to make any of these changes and push them back anywhere. And not only that, you can take any of these resources and you can actually put them in your organization and make them work for you. Now, what I mean by that is different organizations have different compliance measures. They have different different things that they have to adhere to within their org, right? So if you need to register every change with a change manager system, or every time you interact with your database, you got to create a ServiceNow ticket, okay, or something like that, or a Jira ticket as a record of when things happened. You can just write. If it has an API, you can talk to it. Like, it's your code. You can do whatever you want. It's full fidelity to be able to get in there. Now, this is actually very good because what this allows us to do is we can create a new asset pretty easily here. So if I create a new asset, and I mean, it's not the most elegant way of doing it in TypeScript, but it works and it's really nicely. I can say new prop snippet. Okay, we're going to call that prop dev day. And we're going to add that prop into the builder. Add prop. Wait. Trying to type around my head is hilarious. There we go, right? Now we're getting, we're actually getting type annotations. It's telling us it's the wrong one. Prop name, and we're going to add it in here. And let's create that asset. And again, this is happening only in a change set. That asset is not fully available within your organization yet. You're actually only working on that. You know, you're not destroying anyone else's work. And what we can do, if we go back to the model screen, we will get a new one right here, because that's what I called it. And if we click on it, you'll see a new prop over here called DevDay. So it's pretty simple and easy to do. Now, of course, it's super rudimentary. It's super, this is a really simple, contrived example, and it's, we're working to make this scale for thousands of nodes and thousands of different pieces of information. But this is being user tested to be able to help see if we're trying to get that reaction from people, if collaboration is going to work, okay, if full fidelity is going to work for them. And the fact that you can do this, and the fact that it's a digital twin, means we solve that third problem, okay, that source of truth, okay? This is no longer our source of truth. Our source of truth is this plus the upstream environments. And the fact that each of these are continually talking to the upstream environments to understand what has changed, what implications is this going to have, all of these different pieces, we can be much more satisfied that something is going to happen because it's in that state already. Now, where that leads us to is pretty simple. Everything is a function, and I do mean everything is a function in here. It's all just attached functions. And the fact that it's functions means we can write a discovery function. Wouldn't it be amazing if you had a function that just ran in the background that says, show me all of the new infrastructure that is created within Amazon that is not part of infrastructure as code? And it just pops it up and says, look, I found some stuff in the real world. You have no representation of this in your model. Would you like to create it? And that's actually what we're working on at this moment in time. So discovery is going to be one of our key features for people. Now, that doesn't mean that you throw away all the other tools that you use currently and just change the system initiative. That's not the case. What this actually means is possibly you could use a tool like this to help you understand the ecosystem that you currently live in, and you could still use those other tools to manage it, to make the changes, because that's what the developers are comfortable with. And like CTOs, VPs, engineer managers, they can be writing the simulation, they can be writing the changes that they need. I gave a demo of this last week to a friend of mine who works at a large company, and he said they struggle sometimes to understand the implication of when there are CVEs, okay, when there's vulnerabilities within their organization. Okay, if a CVE is released, they need to quickly understand what it affects in the system. So I wrote him a tiny demo, and I drew 8 Docker containers on here. And I made one use internal company Docker containers, and 5 were just publicly Docker containers. And I wrote a tiny snippet of code that says, show me all of the Docker containers on this graph that are open, that are docker.io, that are not made by our company. And all on the left-hand side in the diagram outline, he could quickly see where all of the failures would happen. So he could write a piece of code that says, show me the nodes that run this operating system, or this instance type in Amazon, or that have security groups that are wide open. And he can get it very easily a list that's there so that he can go to his security team, his engineering team, and actually go and be able to fix those holes, those vulnerabilities. So we're trying. We're not quite there. There's a huge amount of work that's available to make this happen, to fix this up and drive this forward. But we're pretty happy with the results. We are, I'm going to say it crudely, you can think of this as a giant actor model. Okay? It is no longer like infrastructure as code, where it is declarative and you say, I need 10 instances running. What you do is you actually say, I need 10 resources in the real world, and then I can attach pieces of functionality to them. So for example, if with an infrastructure as code tool, you can't tell it to reboot your nodes. How you would do that is you would tell the infrastructure as code tool, take it to stop, apply that, make the change in your code, take it to running, apply that, and it'll change it back. I can click the Actions tab right here, and I can say, reboot my instance. And that's part of my workflow, it's part of my system, and the next apply into the real world, it will reboot that instance. Okay, so you have much more control that you can add and attach behaviors to systems, because that's what we think on, right? We don't think of a desired state. We think of actually making changes to run an infrastructure or changes to running systems that allow you to do things in a different way. So it's pretty cool what we're trying to do. It's pretty cool what we're trying to build. Now, the last part here is that we currently have a I forgot you can't see my screen. We currently have a module index. Okay, so we're trying to build this so that people can actually share. Oh, and just to show you, all of the functions are all here. That's built in the system, and you can see everything. Everything is like open. You can extend and change everything. It's not really anything, but we're working on a modules tab, so you can see the local and installed modules. You can see remote modules, and you can actually see, look, Paul test and export. Yesterday I built a new KMS key built-in. I'm working on SQS queues right now. I've made some changes to IAM rules. I'm working on Lambda. So like, you know, these are all modules that are going to be available and people share them, because we kind of know that we're not going to write everything, right? There's no way that we can write a system that's going to satisfy everybody. We want people to be able to go and write their own modules, their own way of working that suits within their organization. We're not trying to force a way of working to an organization that is not designed for that way of working. It's really important. So, until your pretty code is in production making money, you've wasted your time. Is probably one of my favorite ever quotes. And we always must think about that. Okay? Try your best not to get hung up in the details of pull requests and stuff like that. Let's just, you know, facilitate work happening, facilitate work getting released. Let's make our end users happy, our customers happy. DevOps is not dead. Our aspirations were truly correct. We just need to iterate a bit more. Okay? There's no such thing as a finished process in any organization. It's just one of those things. We can't really do anything about it. And if we now think of the quote again, imagine a world where product owners, developers, QAs, InfoSec, security, all of these people can come together and work together by enabling working to get the fast flow of work through into production. That's what we're building. You can see why I stressed it at the start of the talk. Okay, that sentence, that quote rings really true with us. And it is doing everything that we can to be able to facilitate people making this code. You don't have to sacrifice control for simplicity. Shared control is greater than alignment and shared control means alignment and understanding. You need to stop arguing about the semantics, focus on the substance. You need to focus your decisions you need to get feedback on your decisions before you commit. These are the things that are super important to what we want. If we want that world, this world right here, we have to challenge the beliefs, we have to break the rules, we have to think and act differently. For us, it's very, very important that that's the case. And we really hope to be able to inspire an ecosystem based on this. We're not saying we're going to be the only tool that does this. There is already new ways of working in all parts of the ecosystem right now. Okay, Dagger. Anyone heard of Dagger? Okay. You have Winglang. Okay. They're all challenges on an existing problem that we thought was solved, but that people are frustrated by. There's many, many, many more. Okay, there's new UI tools popping up for all sorts of things. Don't be afraid of the UI, right? It might look like it's dragging and dropping and clicking around, but that's okay. Why would you spend 20 minutes writing some code that you have to pass across to somebody else who then has to visualize in their head how that infrastructure code looks like when you can make it visual for them? We're people. We think visually. We don't think and looking at code. We try and understand what the code does. We try and break it down. The first thing we do before we start a new project is we draw boxes and arrows on a whiteboard. Okay? Whether we like it or not, we kind of do. And you might not do it on a physical whiteboard, but you're definitely doing it in your head. This part of the application talks to that part of the application. That part of the application is a completely different area of the code, or it's a different region. We have to think about how multi-cloud works, all these different things. Why not just make it built in? Why do these different things? Thank you so much. You can reach me at this email address right here, but I wanted to leave a few minutes for questions if anybody had any.